Hello, budding doctors and medicals from United Kingdom. I'm Vijay Singh, and today I'll be talking about BMAT Section 2. BMAT Section 2 is all about scientific knowledge and application. So let us look at some of the type of questions that you get in BMAT Section 2. I'm going to start with one past paper question. So this question was asked in one of the BMAT exams, and you see the question says that you have a right angle triangle which has horizontal and vertical sides. So you see the horizontal side is 4 plus square root of 2, and the vertical side is 2 minus square root of 2 centimeters. And the question is to calculate the area of the triangle. They want you to calculate the area of the triangle. So how do you calculate the area of the triangle? So first, let's understand what is the formula for area of a triangle. The area of a triangle is given by half times the base multiplied by height. So technically half times the base, this is the base of the triangle, and this is the height. So when you multiply half times the base times the height, you get the area of the triangle. So let's substitute the values. So you have half, the base is 4 plus the square root of 2. So this is the base, you see, 4 plus the square root of 2, and the height is 2 minus the square root of 2. So that's 2 minus square root of 2. You'll have to do a little bit of math here. So just multiply. So this is 4 multiplied by 2, that gives you 8. And then 4 multiplied by negative square root of 2, that gives negative 4 square root of 2, plus 2 square root of 2 multiplied by 2, that gives you positive 2 square root of 2, and then square root of 2 multiplied by negative square root of 2, that gives you negative 2. So if you try to solve here, this becomes 8 minus 2, which is 6, and negative 4 square root of 2 plus 4 square root of 2, that gives you negative 2 square root of 2. Then since this is divided by 2, you can divide each one of them by 2, and you get 3 minus the square root of 2. So if you look at the options, you have one of the options 3 minus square root of 2. So your right answer is C. So the important thing here is you need to know what is the formula of the triangle, and then you need to do a little bit of simplification. You should be aware how to multiply these irrational numbers. And once you know the formula and how to multiply irrational numbers, this question would be pretty straightforward. Let us take another physics question. Now, this question says you have two identical cars. You see, you have car P and you have car Q. So there are two identical cars, start at the same level. So they start at the same level. Car P moves at a constant speed of 10 meters per second. So this moves at a constant speed of 10 meters per second. And car Q moves at a constant speed of 20 meters per second. So this moves at a constant speed of 20 meters per second. And the car P uh, reaches up to a height of 25 meters. So you see, car P goes all the way till here. So it from the ground it covers a height of 25 meters, and car Q, it goes all the way here and it covers a height of 50 meters. So that's what they say, that they start at the same level. Car P moves at a constant speed of 10 meter per second up a hill of height 25 meters. So you see this is 25 meters in time 20 seconds. In the same time, car Q moves at a constant speed of 20 meters per second up a hill of height 50 meters. So the question they are asking is, which of the following statements are correct for the kinetic energies of the car while they are traveling up the hills, and for the gravitational potential energy once they are on the top? So you need to know what is kinetic energy and what is potential energy, gravitational potential energy. So the kinetic energy, as the word kinetic itself means motion. So the kinetic energy is energy of an object because of its motion, or energy possessed by an object by virtue of its motion. And its mathematical formula is half times mass times velocity squared. So kinetic energy is given by half times mass times velocity squared. And the potential energy is given as the gravitational potential energy is given as mass times gravity times height. Gravitational potential energy means the energy possessed by a body by virtue of its position. So because this car goes up to a height, so it has gravitational potential energy, and gravitational potential energy could be calculated as mgh, and kinetic energy could be calculated by half mv squared. So let's try to calculate the kinetic energy and the potential energy of both the cars. So let's say kinetic energy of car P. Now you know that both are identical cars. Both are identical cars. So let's take the mass of car P as m and the mass of car Q as m, because both are identical, so both the masses are same. However, the velocity of car P is 10 and the velocity of car Q is 20. So let's plug in the values in our formula. So the velocity of car P is 10. So if you plug in the values in kinetic energy, that would be half times mass times 10 squared, which gives you 50 m. Similarly, the kinetic energy of car Q will be half times mass times 20 squared, which will give you 400 m divided by 2, that gives you 200 m. Now, if you see, the kinetic energy of car Q is 200 m and the kinetic energy of car P is 50 m. This means that the kinetic energy of car Q is 4 times the kinetic energy of car P, because this is 200 m and this is 50 m. So the kinetic energy of car Q is 4 times the kinetic energy of car P. Now let's look at the potential energy. So the potential energy is mass times gravity times height. So the potential energy of core P is mass times gravity times 25, because it covers a height of 25. So you have 25 times mass times gravity. Gravity is 10. You could use 10 or you could use G. It doesn't matter, because gravity will be the same for both the cars. Now, potential energy of car Q is mass times gravity times 50, because this height is 50. Now, when we do the calculations, we see that the potential energy of car P is 25 mg, and the potential energy of car Q is 50 mg. This means that the potential energy of car Q is 2 times the potential energy of car P. So now we have got the potential energy comparison as well as the kinetic energy comparison. So kinetic energy of car Q is 4 times the kinetic energy of car P, and the potential energy of car Q is 2 times the potential energy of car P. So if you look here, the options, we have option C, where it says the kinetic energy of car Q is 4 times as much as that of P, and the gravitational potential energy of car Q has twice as much as of car P. So your C is the right answer. All right, keep watching my videos. I'll be uploading more videos, and I'll be covering almost all the questions from BMAT Section 2, Scientific Knowledge and Application. Till then, have a lovely evening.